Okay, geometry, section 2.1, conditional statements. Our objective for this lesson is we want to be able to write conditional statements, use definitions written as conditional statements, and be able to write biconditional statements. Okay, I want you to, this last one, make truth tables. Go ahead and cross that out. We're actually not going to be doing that this section, so we're going to be skipping out those truth tables. I forgot to edit that out. Okay, so we're going to be doing conditional statements. So this is an introduction to logic. Logic is a whole different set of study in mathematics and geometry, but we'll need an introduction to it to be able to get into proof writing. Proof writing is a huge part of our geometry course, so we'll need to have an intro to proof writing. So we're going to start with the basic conditional statement. Really what a conditional statement is, it's just a logical statement. So it's a logical statement with two parts. With two parts. The two parts are called the hypothesis that we normally use a lowercase p for, and the conclusion, which we use a lowercase q for the conclusion. Okay, a conditional statement can be written in, for example, let's do some random conditional statements. If I skip class tomorrow, then I'll be grounded. Okay, that's a conditional statement. If I throw this ball in the air, it will hit the ground eventually. Okay, so kind of just any type of conditional logical statement with two parts. Okay, so conditional statements can be written in if-then form. You must not have read my door, huh? All right, sorry about that interruption there. So conditional statements can be written in what we call if-then form. Okay, where it's if something, then something. Okay, if something, then something. Okay, and so this first thing behind the if, so this bit behind the if is what we call the hypothesis. Okay, that's where the hypothesis is going to be. And the part behind the then is the conclusion. Okay, for example, if I was to say, if I'm a 10th grader, then the conclusion would be, well, I'm a sophomore. Okay. So if I'm a 10th grader, then I'm a sophomore. Okay. So that is an example of a conditional statement. The hypothesis is I'm a 10th grader. Okay. The conclusion is I'm a sophomore. Okay. So that is a conditional statement. Okay. So not all conditional statements are in if-then form. So we have to sometimes put them into if-then form and determine what part is the hypothesis, what part's the conclusion. Okay, so you always have to ask yourself, which part must you have to know first for the other? Okay, so to identify the hypothesis and conclusion, then we want to rewrite the conditional statement in if-then form. Not all of them are written in if-then form to start with, but they can all be written in if-then form. So for this one, we have here, all birds have feathers. Okay, so after shell here, what are we starting? We're starting with the fact, and it doesn't all necessarily go in order. It always depends on how the sentence is structured. So here we have all birds have feathers. So to write this in if-then form, okay, first we have to identify what part's the hypothesis, what part's the conclusion. So here we're saying that we're starting with the fact that we have birds and then something birds have. So we're starting with the fact that we know it's a bird, and then we're going that it has feathers. So that tells me that the hypothesis is we have a bird. Okay, so the hypothesis here is it's a bird, right? So this is the hypothesis, and the conclusion then would be that it has feathers. Okay. To write this in if-then form, I'm going to have to add some words to this, okay? Because it wouldn't make sense for me to write if all birds then feathers, okay? That grammatically does not make sense. So we're going to start with if. Let's go if, let's add some words here. If an animal is a bird. So if an animal is a bird, comma, then it has feathers. Okay. So if an animal is a bird, then it has feathers. Okay, so we had to add a bunch of words into that so grammatically it made sense. Okay, so make sure you're adding appropriate words in so that we kind of still follow the English rules as far as writing sentences. Okay, so again, our hypothesis would be an animal is a bird. Our conclusion then would be, well, it has feathers. You notice how I don't include the if in the hypothesis. This if is not part of the hypothesis. This then is not part of the conclusion. The hypothesis is an animal is a bird. The conclusion, it has feathers. Okay? So now to talk about the true and falseness of this, to determine whether this is true or false, okay, we have to ask ourselves if the hypothesis is in fact, if the hypothesis is in fact true, does that mean that the conclusion is also true? So for the whole statement to be true, the hypothesis is true, the conclusion must also be true. So if I have a random animal and I say, okay, my animal is in fact a bird, then does it in fact have feathers? Yes, and that's by definition of bird. Okay, if we look up the definition of a bird, it has to have feathers. Okay, like even penguins have feathers, even though their feathers are kind of weird, they still do have feathers. Okay, so if an animal is a bird, then it has feathers. That's a true statement. Okay, so let's go ahead and let's look at this next one. Okay, it's you are in Texas if you are in Houston. Okay, so now we have to determine what part's the hypothesis, what part. Okay, it says you are in Texas if you are in Houston. So they kind of give you that if there, but the if's in the middle. Okay, so we have to figure out which comes first. Well, the fact that comes first is, well, you're in Texas, so if you are in Houston. So this part, if you say, yeah, I'm in Houston, then you're in Texas. So that tells me my hypothesis is actually back here. You are in Houston. That's the hypothesis. The conclusion is actually this one part here. Again, you always have to ask yourself, what information do you know first? Well, in this case, first you know that you're in Houston. Okay. So then you are in Texas. So to write this in an if-then statement, this one kind of has it laid out for you because of the if right there in that. So if you are in Houston, capital, then you are in Texas. So again, hypothesis is, well, you are in Houston. Conclusion then would be, well, then you are in Texas. Okay, all right. Okay, so now that we know what a general conditional statement is, now we need to talk about the negation of it. Okay, the negation is a statement that is opposite of the original statement. Okay, so it needs to be opposite of the original statement. Okay. It generally involves the word not, either adding in the word not or removing the word not. Okay. So, oh, we forgot to talk symbols. Oh, back it up, guys. We need to talk about some symbols here. A conditional statement, we talk about, okay, we go down to our hypothesis is P, our conclusion is Q. So to write this in symbols, a lot of times, we could write it in words. We would write if P, comma, then Q. But in mathematics, again, we really like to shorten this up. So we could just write P, and then we use this little arrow. Sorry, I think it needs to be an arrow. P, arrow, Q. So this guy, P, arrow, Q, means the same as if P, then Q. And we would read this as P implies Q. Meaning if P happens, then that implies that Q happens. So P implies Q. So to get us used to that shorthand notation there, okay, So we would go P implies Q. We just use that P and Q a lot because when we negate something, the negation symbol is this little tilde symbol. It's a tilde. Tilde. Okay. It's that little tilde symbol that we use above our congruent sign. That's it. But we use it without the equal part. Okay. So we don't put that equal part on it. It's just that tilde sign. So that means the negation of it. So here, if I wanted to just say not Q, okay, I would put that little tilde, and basically that means, oh, sorry. This little tilde sign basically here means not. Okay, so if we want to write the negation of each of these statements, the ball is red. Okay, we want the complete opposite of that. So I wouldn't say the ball is blue, okay, because that's not the opposite of red. Okay, if the ball is red, then the negation of that would be, well, the ball is not red. Okay, it's the complete opposite of that statement. Okay, so it always, a lot of times involves the word not or removing the word not. Here, the cat is not black. Okay, so the negation of that would be, well, the cat is black. Okay, we removed the not. So normally it means adding or removing that not. Okay, all right, so we have our conditional statement right here, our conditional. Okay, but then there's also these three other related to it because we can negate our statements or we can flip-flop them and switch them around. So we have words that mean like flip-flopping or switching them around. Okay, so a conditional statement is just our general if P, then Q. If P, oh, then Q. And we would write that in symbols as P, again, implies Q. Okay. But I could flip-flop my hypothesis and my conclusion around. So that's what we call the converse. So the converse flip-flops the two. That's the converse. Okay, so instead of saying if P, then Q, I would say, well, if Q, then P. And we would write that as Q implies P. So if I flip-flop the hypothesis and conclusion around, that's called a converse. Okay? The inverse is the negation. So inverse, I negate the original conditional statement. So instead of saying if P, then Q, I would say, well, if not P, then not Q. Okay? If not P, then not Q. So again, we'd write that. So I'd go not P with tilde symbol implies not Q. Tilde symbol. Ooh. Oh. Sorry. Not P implies. Oh, I have no idea what just happened there. Not P implies not Q. Why won't it let me write a Q? There we go. Not P implies not Q. So if I negate both statements, okay? And then the contrapositive does both. It flip-flops and negates, okay? So I would flip-flop, put the Q first, then the P, and then negate them all. So it'd be if not Q, then not P. Okay, so we'd go not Q implies not P, okay? Okay, so it flip-flops them and negates them. So it does both what the converse and inverse do. Okay, and it's important to note, just because the conditional is true, doesn't mean that all the rest of them will be true. If we go back and look at some of our others that we did, this Texas one, if you are in Houston, then you are in Texas. Okay, if I just flip-flop these, the converse, flip-flop them. If you are in Texas, then you are in Houston. That's not true. I could pick a random person in Texas. That doesn't necessarily mean they're in Houston. Okay, so I could pick somebody in Dallas. Okay, they're in Texas, but they're not in Houston. So the converse in that case is not true. Okay, but if I negate them, if you are not in Houston, then you are not in Texas. Well, that's not true either, if I negate them both. Because you think about it, okay, if I'm not in Houston, let's say I'm in San Antonio. Okay, well, am I not in Texas? No, I'm still in Texas. Okay, so that's not true. Whereas if I flip-flop and negate them, if you are not in Texas, then you are not in Houston. Well, that's true. If I'm somewhere not in Texas, I don't know, Massachusetts, well, then obviously I'm not going to be in Houston. So we have here some equivalent statements. We noticed on that, when I just flipped it, it wasn't true. So my converse wasn't true in that case. When I negated them, it wasn't true. But when I flipped and negated, it was the same as the conditional. So those are equivalent statements, meaning the conditional and its converse mean the exact same thing. So whether you have the straight if P then Q, and then if the not Q, then not P, if one's true, the other's true. Those are, down here, equivalent statements. The conditional and the contrapositive will either both be true or both be false, because they mean the exact same thing. Okay, but then so does the converse and the inverse. They mean the exact same thing. So if the converse is true, the inverse is true. If the converse is false, the inverse is false. They are equivalent statements. Okay. Okay, so now let's write some conditional statements. So let P be you are a guitar player, and Q be you are a musician. Write each statement in words, then decide whether it's true or false. We want the straight old conditional. P implies Q. So in words, we would write, well, if you are a guitar player, comma, then you are a musician. Okay. Now I have to decide, is that true or false? Well, if you're a guitar player, musician just strictly means that you play music. Okay. So if you're a guitar player, do you play music? Well, sure you do. So that would make that true. Okay. Big T for true. Okay, so now the converse. Converse is we just want to flip-flop the two. Okay. So I'm going to start marking. Okay, hypothesis, right? So there's the one. Okay. Conclusion, you are a musician. So now we want to flip-flop those two things. So we'd flip-flop. If you are a musician, if you are a musician, comma, then you are a guitar player. Okay. All right, so let's think about that one. You're a musician. You play music. Okay, so I think about somebody who's a musician. Does it necessarily mean they're a guitar player? No. I can have this first part be true. Sure, you can be a musician. Second part be not true. You don't play guitar. They can play piano. They can play the tuba. They can play the drums. So that would be false. Okay. If you're a musician, then you are a guitar player. That would be false. Okay, so now the inverse. I want to go back to the original statement. If you are a guitar player, then you are a musician, and I want to not it. I want to negate both of those. So if you are not a guitar player, then you are not a musician. Okay. So I'm thinking of someone who's not a guitar player. Okay, some random person who's not a guitar player. Does that mean they're not a musician? Not necessarily. They could play drums. Well, they might not be a musician, okay, but it always the first has to imply the second is true. If the first is true, so if I have somebody who's not a guitar player, okay, one off the top of my head, I know Kyle Meyer's not a guitar player. He plays drums, but he's not a guitar player. Then you are not a musician, but he is a musician, so that would make that one false, which makes sense because I need the converse and the inverse mean the same thing. They're equivalent statements. So if one's false, the other's false. Okay. All right, and the last one, contrapositive, we want to flip-flop the two around and negate. So if you are, we'd have to go not a musician. So we have someone who's not a musician. Then you are not a guitar player. Well, if we have the first bit true, you're not a musician. Okay, don't play music at all. Well, then that means, yeah, you don't play guitar at all. So that one would be true as well, which makes sense because we want the conditional and its contrapositive are equivalent statements. If one true, the other's true. Okay. All right, so you can actually use conditional statements in if-then form and its converse to write a definition. Okay, so for a definition, both the converse and its conditional statement are both true. So for a definition, both of these, the conditional and the converse, must both be true because you'd want it to go both ways for a definition. So we can actually look at the definition of perpendicular lines. Okay. So perpendicular lines in if-then form is if two lines intersect to form a right angle. So there's our hypothesis, comma, conclusion then would be then they are perpendicular lines. Okay, so perpendicular lines are two lines that intersect to make a 90-degree angle. You have a 90 right angle there, because we know a right angle there is 90 degrees. Okay, so we could also write the converse of this. The converse is, again, we flip-flop the two. So we could say if two lines are perpendicular, comma, then they intersect to form a right angle. Okay, so we have both the conditional. If two lines intersect to form 90 degrees, so there's my conditional right here. Here's my converse. Conditional, converse. Okay, so for it to be a true definition, it has to be both conditional and the converse. So that means all four of those statements are true in that case. Okay. All right, so let's go ahead and let's look. Decide whether each statement about the diagram is true. Explain your answer using the definition you have learned. So, perpendicular, we have a new symbol here. We have this weird symbol in here, like this. That is our symbol for perpendicular, okay? So our symbol for perpendicular here, if this is line, let's call this line lowercase m, this line lowercase l. So I'd say lowercase m perpendicular to lowercase l. Okay, so that's our symbol for perpendicular. We'll be using that all year, so make sure you know it. That's our symbol for perpendicular. Okay, so to decide whether each statement about the diagram is true. So here we have line AC. They're saying line AC, which line AC right here, with the highlighter. Line AC right here is this line right here, that pink one. And we have line BD. Line BD, here's this blue one. Okay, are they perpendicular? Well, we can see here that 90-degree angle. So I have two lines, they intersect at point E to make a 90-degree angle. So is that true? Yes, that one would be true. So it's true. Explain your answer using the definition you have learned. Well, what do they say? They intersect at 90 degrees at a right angle. So by their definition, then they are perpendicular lines. Because we said if two lines intersect to form a right angle, which we have, then they are perpendicular lines. Okay, so we have two lines intersecting at a right angle. Okay, so now we have next one, part B, angle AEB. Okay, so I'm going to go ahead, I'm going to delete there. I know it's a lot harder for you to delete your hand highlighting. Okay, angle AEB. Okay, we have AEB. Okay, and angle CEB. Angle CEB are a linear pair. Well, linear pair needs to be adjacent. Well, they are. They're side by side. They share a side, so they're adjacent. And they add up to, because if I know this is 90, then I know this is 90. So, yes, that's true. And that's really by definition, because of the definition of linear pair. Linear pair, they're side by side. They add up to 180. Definition of linear pair, they are adjacent and supplementary, meaning add up to 180. Okay, right, so now the last one. Oh, I'm supposed to be erasing. Okay, ray EA, so we've got ray EA and ray EB. It says are opposite rays, EA, EB. One's heading west, one's heading north. That means no, they are not opposite rays. That would make that false. They aren't on the same line. They have the same endpoint, but they aren't on the same line. They have to be in the same line, or we could say they're not going opposite directions. Okay. All right, we have one last little thing to talk about, and that's a biconditional statement. Okay, if a conditional statement and its converse are both true. Are both true. You can write them as one single, you can write them as one statement. And that is what we call a biconditional statement. Okay, so, and how we would write that is we would say P and we'd use the words if and only if Q. Meaning, what this if and only if tell us there in the middle is it goes either way. You could go P implies Q or Q implies P. In symbols, we would write it as P arrow, but then we put an arrow on the other way, Q. So this tells me it can go either way. P implies Q or Q implies P. That is what we call a biconditional statement. It has that if and only if in the middle. If you notice, there's no if out in front of this P, because it's just hypothesis, if and only if Q, because that means it can go either or. Okay? So if we look at our definition for perpendicular lines, here's our definition. If two lines intersect to form a right angle, then they are perpendicular. Hypothesis, two lines intersect to form a right angle. Conclusion, they are perpendicular. So we can write this as one single biconditional statement, basically using if and only if in the middle. So we would start with, well, two lines intersect to form a right angle, and then we use the words if and only if and only if they are perpendicular. Okay. So really what this if and only if tells us right there in the middle, that if and only if, that the hypothesis and conclusion here could be very easily interspersed. Hypothesis could be conclusion, conclusion could be hypothesis. It goes either way. Okay? So that's a biconditional statement. Okay? So that is the end of our notes. Go ahead and get started on your practice.